Good morning, grade 12s. It's Mr. Nambani again. We continue with a series of videos that we did for acids and base. So for you to catch up with what we've been doing, it's important for you to watch part 1 up to part 5 because today we'll be doing part 6. But generally from part 4 to part 6, we're dealing with the previous question papers, giving you approaches that to how best can you answer questions. So the easiest way of doing that is kindly watch the videos from part 1 until the last part. Is then that you'll be able now to have a consolidated idea and approach of how best can you go in terms of answering acids and base. I did say it's quite an easy topic, but now the challenges thereof are only based on whether do you understand the principles, do you understand the theories. If you do so, then everything somehow will be easy. So today I've just taken an extract maybe from 2 different question papers. So we'll be dealing with that because this video should be just an hour. So we'll be trying by all means to emphasize on more of the important key things. So I have now chosen to go with question 7, and the reason for question 7 is majority of questions that we've been doing, there was no one that now asked us to define the hydrolysis of a salt. So hydrolysis in simple terms as per definition at 7.1.1 now, we'll say now hydrolysis is the reaction between salt and water. So the key words there is the reaction between salt and water, and then it will be easy, 2 marks by so doing. So hence we said it's important now let's have an emphasis in terms of the definitions. Once my definitions, I'm able to give the definitions, the very first part of the question, I will always somehow be able to get or achieve maximum marks. Moving further on, it says here, will the pH of the solution be greater than, smaller than, or equals to? And then with a relevant equation, support your answer. But now let's read again what the question was exactly trying to ask from us. It's saying a learner dissolves ammonium chloride crystals in water and measures the pH of the solution. So now it means in this reaction, I'm going to have my ions here, which is ammonium ions, that now will react with water, and the reaction will be now NH3 plus H3O plus. So now it clearly says to me, but from this reaction, I am producing more now of hydronium ion. So I have an increase in the concentration of hydronium ion. And if this is the case, it says to me now, I am going to have an acidic salt, so thereof the pH should be now less than 7. So if it's less than 7, it says to me the only correct answer here should be smaller than. So smaller than 7. Then I will be able now to get a mark for that. But I was not going to be able to get the correct answer if I was not able now to write the above equation to show me that now I have an increased concentration of H3O plus. Remember, H3O plus is associated now with acids. So if it's associated with acids, if it's increasing, it means now my pH scale now will move towards lower values. So if it's moving towards lower values, it must be smaller than 7. So The reason why I started with the equation is for me to understand now the hydrolysis of the salt. So from the hydrolysis of the salt, it's easy that the ions are reacting in water to have an influence on the pH value. Hence, I was trying to say, before I can answer, what is the end product of this particular reaction? So the end product thereof is producing H3O+. If H3O+ is produced or it's increased, then automatically we say the pH should be smaller than 7. So the above equation is definitely the reason for that. So it will be 1 for having your reactants, as well as 1 now for having the products. So it will give you 3 marks there. Then we further move on and say at 7.2, sulfuric acid solution is prepared by dissolving 7.35 grams of H2SO4 in 500 centimeter cubed of water. So it says now calculate the number of moles of H2SO4 present in this solution. This should not be a problem, because now if they ask us to calculate the number of moles of H2SO4, this will be my number of moles initial. That is what I am starting with. So this is what I want to calculate. But what else do I have? I am given the mass of H2SO4, which is now 7.35 grams. Then the other thing is I can calculate the molar mass now of H2SO4 to be 98 grams per mole. So this is just the data and the information that is given to me. So the relationship between molar mass and mass, it's M of H2SO4 is equals to the molar mass divided now, the mass divided by molar mass, which is now 7.35 divided by 98. Then our final answer will be something like 0.07575 mole. So this is a basic way of calculating number of moles. It comes even from our topics in grade 10, grade 11. So it's now in grade 12. So it says somehow I also need some information from grade 10 and 11 for me to be able to answer certain questions. So with that being said, let's look at the mark distribution. It will only be 1 mark, and then 1 mark now for the use of 98. The formula does not have a mark in this case, so hence we'll only get 2 marks. It further goes on to say, but this number of moles, according to the statement that is given, a sulfuric acid solution is prepared by dissolving 7.35 grams of H2SO4 in 500 centimeter cubed of water. So it's basically saying this is the number of moles that I am starting with. So calculating this number of moles, I can easily say these are my now initial number of moles for H2SO4. The reason why I need this is somehow I am going to need this value for me to continue with other calculations thereof. So we further move on and say, but now at 7.21 also, sodium hydroxide pellets are now added to 500 centimeter cubed of H2SO4 solution. The balanced chemical reaction is as follows: H2SO4 plus 2 sodium hydroxide will give you now Na2SO4 plus 2 H2O. After the completion of the reaction, the pH solution was found to be 1.3, and assume there's complete ionization of H2SO4. Thereof, now calculate the mass of sodium hydroxide that is added now to the solution, and then assume that the volume of the solution does not change. So it becomes quite tricky in this manner, because now we need to look for what is it that we have and somehow be able to relate the given information to the statement as it is. So the very first thing is, I am given at 7.22. I am given the pH. pH is equals to 1,3. So the question is, if this pH is 1,3, how best can I use it in order for it to assist me, because it will not be given to me and then not be able to assist me in terms of getting the correct answer for this one. So the best way is, what relationship do I have, or any information that I have of pH? So the very first thing we'll say now, the pH is equals to minus the log the concentration of H3O plus. So it will be 1,3 minus the log of concentration of H3O plus. So with this, it says now I can be able to calculate the concentration of H3O plus. So the concentration of H3O plus, taking the antilog concentration of H3O plus, will be now just 10 minus 1,3, which will be equals to something like 0.05 mole per decimeter cubed. But now, this is the concentration of H3O plus. It's not the concentration of H2SO4, of which maybe if I have, I will be able to link it with sodium hydroxide. So what do I know in terms of complete ionization of H2SO4? I know that now H2SO4 in water will now produce SO4 2 minus plus 2 H3O plus ions and 2 water then. So this is now a complete ionization reaction of H2SO4. So this is a complete ionization reaction of H2SO4. So from this, I am able now to say, but now if I am comparing H2SO4 with H3O plus, the ratio there will be 2:1, but I'm interested in getting the concentration of sulfuric acid. But the concentration of H3O plus was already given, which is now 0.05. Then for me to get X, which is now the concentration of H2SO4, it means I must just now divide 0.05 with 2, which will give me something like 0.025 mole per decimeter cubed. So this X now, it is just the concentration of H2SO4. The concentration now of H2SO4. So now that I have the concentration of H2SO4, it's easy for me to relate that in terms of the number of moles. Because if I have the concentration, I can easily get the number of moles, and then from the number of moles, use my molar ratio in order for me to get anything that has to do with sodium hydroxide. Remember, the question is calculate the mass of sodium hydroxide, but there isn't any information given to us in terms of sodium hydroxide. So we need to move from the information that is given to the information that is not given. So in this case, all the information we have somehow relates to the acid, which is H2SO4. So once I am happy in terms of the information I have about the acid, automatically I can be able to use my molar ratio and compare the two. So now I have the concentration of which I calculated. So I can easily say, but now this concentration is the concentration of H2SO4 that is in excess. So let me calculate now the number of moles of H2SO4 that is in excess, which will be just equals to CV. The concentration is given, it's 0,025. This is what we just calculated. And then the volume also was given now in a solution of 500 centimeter cubed. So in that solution of 500 centimeter cubed, it means now my volume here should be 0,05. Then I will be able to get the number of moles, which is 0,012525 mole. So I must highlight that now this is the number of moles in excess. This is the number of moles in excess. But now if you check, we calculated initially the number of moles of H2SO4, which was 0,075, and then we further moved on, calculated now the number of moles of H2SO4 that is now in excess. So it means I can easily get now the number of moles of H2SO4 that has now reacted with sodium hydroxide. So it will just be the number of moles that I started with, which is 0,075, minus now the number of moles that were in excess, which is 0,0125, and then I get the number of moles. So the number of moles is 0,0625 mole. So this is the number of moles that has reacted with sodium hydroxide. So this is the number of moles that has reacted. So I want now somehow an information that I will be able to link this number of moles that has reacted with the number of moles of sodium hydroxide. So the only way of doing that is now to look and check into my molar ratio, because the molar ratio is the one that now allows me to be able to move or link the two in terms of what is it that is given and what is it that is being assessed. So now that I have the number of moles of H2SO4 that has reacted, I can easily go back now to my balanced chemical equation and say what is the molar ratio between sodium hydroxide and H2SO4. So I will easily say the number of moles of H2SO4 over now the number of moles of sodium hydroxide is just equals to 1 over 2. So the 1 over 2, the 1 comes from the H2SO4, and then the 2 comes from the sodium hydroxide. Then I can easily say, for me to get the number of moles of sodium hydroxide, I will just multiply that 1 by 2, then I will get 0,0625, which is just equals to 0,125 mole. So this is now the number of moles of sodium hydroxide. So this is the number of sodium hydroxide moles that has now reacted with the sulfuric acid. But now that I have the number of moles, it becomes very easy for me to get the mass, because I know that I have a good relationship in a sense that when I have the number of moles of sodium hydroxide it's easy for me to link it with mass and to link it also with its molar mass. So it becomes easy, but now the challenge was I able to understand that when I am given the pH, I can easily move from the pH and be able to get the concentration of H3O+. So once I have the concentration of H3O+, can I use now the complete ionization reaction for me to get the concentration of H2SO4? 100%. So the idea here was, let's move now, instead of being asked to calculate the pH or the concentration of H3O+. In this sense, we're given the pH, this is where we started, and then from the pH now, we move to a point that we want now to get the concentration of H2SO4. So the linkage between the two, it's quite easy to understand that from the pH, you can only get the concentration of hydronium ions. From the concentration of hydronium ions, you now use a complete ionization reaction of H2SO4, and from that now you use the molar ratio, which is 1:2, 1:2, in order to get now the concentration of H2SO4. So once the concentration of H2SO4 is calculated, we further move on to get now the number of moles, because I have the concentration, which is 0.02, I have the volume, which is 0.5, and then I get the number of moles that is in excess. But initially, I was asked to calculate also the number of moles of H2SO4. So from the number of moles, I can easily get now the number of moles that has reacted, and then use now my molar ratio to link the information that is given with the one that is being asked, or the unknown in this case, and then get the number of moles. Once I have the number of moles, it will be quite easy for me to calculate the mass. So the number of moles will be 0.125, and then we want the mass. When I calculated the molar mass, I got something like 40. Then it means mass of sodium hydroxide is just equals to 5 grams, and then this will be your final answer. So the challenge here is the distribution of marks, because if you check, it was a stoichiometric calculation and it was around 9 marks. So the best way of me getting maximum marks out of this is just to work from the information that is given, moving further down, because it's a way of you work with the information that is given, you relate the information that is given with the unknown in terms of the molar mass, the molar ratio, then somehow you'll be able to get and achieve maximum marks. So for now, let's look into the mark distribution of this particular question. So they say you'll get a 1 for the correct pH equation. You'll get another 1 also for substituting the pH value, and then you'll get another 1 for the use of the ratio. Then you further move on, and then you get now another mark for calculating or using the 0.5. You get also another mark for the subtraction of initial and excess, and then you get another mark now for using the molar ratio, and then you get a mark for the number of moles is equals to m over molar mass, and then the final answer will be now given a mark as well. Then you'll be able to achieve and get your 9 marks. It's quite a lengthy calculation, but the principle is very clear. So you work from the information that is given and towards achieving the goal of getting your number of moles. So if you check even the previous videos, there's a great link in terms of once you have the number of moles, once you have the balanced chemical equation, it's quite easy to link the information that is given, in a sense that it will assist you to be able to get now or move in terms of linking the information that is given with the information that is being assessed. So it was quite easy, but the principle was difficult in the sense that you somehow needed to know the complete ionization of sulfuric acid. So from the complete ionization of sulfuric acid is then we are able now to link the concentration of H3O plus with the concentration of H2SO4. The reason for that was in the equation given, there is no H3O plus. So I cannot work with the concentration of H3O plus here. But I should be able now to link the concentration of H3O plus with the concentration of H2SO4. So once I have information on H2SO4, then it becomes easy for me to link the acid and the base in this neutralization reaction. So that the total of this question was just 16 marks. So, but even before the 9 marks, you should be now able to achieve and get majority of marks there. So that was question 7. So we'll go quickly to question 8. We'll quickly go to question 8. And I hope that all these questions are now becoming clearer, and then you will be able somehow to answer any questions that are related to acids and base. So let's look at question 8. With question 8, it says now, ethanoic acid is an acid that ionizes incompletely in water, according to the following balanced equation. Write down the term used for the underlined phrase above. So they are asking a definition basically, but now if you don't know how to define your acid, you don't know the relative strength of the acids, somehow this will also look as if it's somehow complex or complicated. So the only thing I know is that if an acid does not ionize completely, or it ionizes incompletely or partially, then it means for me somehow it has to do with the acid being a weak acid, because we define now a strong acid as an acid that ionizes completely, and then we define a weak acid as an acid that ionizes incompletely. So because of this, I am able now to link that with a weak acid, and then I will automatically get another 1 mark. Then an ethanoic acid solution has a pH of 4 at the 25 degrees. Calculate the concentration of hydronium ions H3O plus in the solution. So we are given the pH that is now at 8.12. pH is equals to 4. Then the question wants us to calculate H3O plus. So I will be able to say, but now from the information that is given, pH is equals to minus the log of concentration of H3O plus. Then I have my pH, which is equals to 4, minus the log, the concentration of H3O plus. Then I further move on to say I need to take the antilog, and then the antilog will be 1 multiplied by 10 to minus 4, which will give us the concentration of H3O plus, and then we can assign the SI unit to this to be mole per decimeter cubed. Mole per decimeter cubed. And this will now be your 3 marks. It will be 1 for the correct pH equation, and then 1 for the substitution, and then 1 for the final answer. Hence, you'll be able to get now a 3 for that. So quite easy. It was a straightforward question, so you should be able by now to have the 4 out of the 17 marks. It further goes on and says a standard solution of potassium hydroxide is prepared in 250 centimeter cubed volumetric flask during a titration. 12.5 centimeter cubed of this solution neutralizes 25 centimeter cubed of 0.16 mole per decimeter cubed of ethanoic acid solution. Then the balanced chemical equation is given thereof. Let's read the question there. It says now at 8.2 define a base according to Arrhenius theory. So at 8.21 we define now a base according to Arrhenius theory. And then a base according to Arrhenius theory is a substance that produces hydroxide ions in water. Hydroxide ions in water produces now hydroxide ions in water. So the key words here, produces hydroxide ions in water, and then it will be 2 marks, and then you'll get your 2. So this just shows how important is your definitions, because from the definitions it's easy to apply the principle. The definitions informs what's going to happen moving further down. So when we go to the question again, it says now calculate the mass of potassium hydroxide used to prepare the solution above in a 250 centimeter cube of the volumetric flask. So they want us to calculate the mass. But what do we know? We know that the standard solution of potassium hydroxide was prepared, and during the titration, this solution was neutralized now by 25 centimeter cubed of 0.16. So we have now neutralization reaction that is taking place. At the very same time, we know it is a titration. So I can easily now focus more on my titration equation. So from my titration equation, that is now 8.22. So my titration equation is CaVa over CbVb, which is equals to Na over Nb. But the reason why I am writing the equation first is it going to assist me in terms of getting the correct answer? Is it going to assist me in terms of moving in such a way that at the ultimate end I am able now to get the mass or even the number of moles? Then if I have the number of moles, it's easy for me to calculate the mass. Can I link now the concentration with the number of moles so that I can get the number of moles? If yes, then it's somehow going to be easy for me to say, but I can easily link up the mass with my number of moles. So the idea here is, let me first try to get the concentration, maybe, depending on the information that is given, because now the molar ratio I am going to get now from the balanced chemical equation. So from the information that is given, I am able to say, but the volume of the acid and the concentration of the acid were given. I have 25 centimeter cubed and 0.16 mole per decimeter cubed. So I have the concentration, which is the volume, which is 25, and then I have the concentration now, which is 0.16. now divided by, do I have the concentration of the base? I do not have the concentration of the base, but the only thing I know is that 12.5 of centimeter cubed of this solution was used. So I don't have CB, but I have now the 12.5. Do I have the balanced chemical equation? Yes, I have the balanced chemical equation. So from the balanced chemical equation, it's easy for me to see that the molar ratio is 1:1. So when I do the calculations and solve now for CB, CB is equals to 0.32 mole per decimeter cubed. So this is the concentration of the base. I must say it's concentration of KOH. This is important for us to know because we don't want to be mixing things up using values for the acids, whereas some values are for the base. So I kindly somehow inform yourself, write it down to say, but whatever I have calculated is for the base, yes, but the base is KOH. So now, once I have that, is there a way of me linking the concentration with number of moles? Because if I have the number of moles, somehow I know definitely that I will be able to get my mass. So the idea with stoichiometry calculations is once you have the number of moles, it's easy for you to calculate everything that somehow is being asked. So can I link the concentration with the number of moles? Yes, I can. I can easily say the concentration of KOH is equals to the number of moles over now the volume. But the volume that was given of the solution is 250 centimeter cubed. We just now calculated the concentration. So it's easy for me to say 0.3 will be equals to the number of moles over now the 0.25. The 0.25, remember our volume is given in 250 centimeter cubed, so we need now to convert to decimeter cubed. Then the number of moles now of KOH will be equals to 0.08 mole. And now that I have the number of moles, somehow it should be easy in a way that I am able to say the number of moles of KOH now is equals to molar mass divided by molar mass. Then it's easy for me to say, but the number of moles is 0.08. The mass thereof is what I'm being asked, and then the molar mass is 56. Then the mass should give me something like 4.48 grams. So I have answered the question. I have managed to get to a point where I am able to link now the information given to what is being asked. So the fact that I was told that it is neutralization, at the very same time it is titration, so I confidently went on and choose the titration equation. From the titration equation, I was able to say, but now what other information do I have? Do I have information about the concentration of the acid, concentration of the base, volume of an acid, volume of a base? So with that being said, I was able to say 100% now I am able to say I have 0.1625 CB, and then the 12.5 of this solution was used to neutralize this particular acid. Hence I linked that up. So after the calculation of the concentration, I further moved on now to link the concentration with the number of moles. Because once I can get the number of moles, it's easy for me now to calculate for for mass. So I used that concentration calculated at the top, and then the volume of the solution, which was 250 centimeter cubed. Thereafter, we got our number of moles. So if the number of moles is calculated, this equation we are familiar with, it's just mass over molar mass, and then the molar mass we can easily calculate from the periodic table. Then finally you'll get 4,48 grams. So you can easily tell the first question that we dealt with was 9 marks. So the other question now is 7 marks. So what does this say? It says somehow in an exam you'll get all these long questions that relates to stoichiometric calculations. You will get information in a way that you are expected to perform this multi-step problems. So with multi-step problems, the easiest way is take it step by step, in a sense of working with the information that is given and making sure that you know how to link the information that is given to the information that is being asked. So I hope now this one is quite clear and it was explained in detail how we approach that. The only thing we need to do now is let's check for the distribution of marks, as it is 7 marks. So it's 1 mark for the formula, and then 1 mark now for the substitution of the concentration, and then there's a mark also for molar ratio, and then there's a mark also for substitution of the volume, and now lastly it's the use of the 0.25. So it's 1, 2, 3, 4, 5, 6, but it says we need another mark. The other mark now is for the calculation of the 56 there, so it will give you your 7 marks. So it's quite an easy thing of doing, a calculation to perform, but the challenge honestly will be if you don't understand the statement, if you don't understand what is being said by the statement, the hints that are given, there is no way you will be able now to understand why was the titration equation chosen, why was the now molar ratio used. So the molar ratio, like we said, it comes now from the balanced chemical equation. At times the balanced chemical equation is given, at times you'll be expected to write one. So either way, know how to write complete balanced chemical equations, at the very same time be able now to perform calculations that has multi-steps in it. Then at 8.23, the question is, will the pH of the solution in the conical flask at the end point be greater than 7, smaller than 7, or equals to 7? Now, remember from the previous videos we spoke about the MBP. You should be familiar with that. We also spoke about A and B, and when can we know that we are going to have a pH greater than 7 or less than 7, and so forth. So I'm going to try and remind you quickly without wasting any time to say MBP, when then we said we have A and B, and then we said now this side we have my indicators, which is methyl orange, bromothiamol blue, and then I have my phenol phthalate here. And then I said this one, A, is for acidic, and then this one is for neutral, and this one is for basic. And then we said now for us to get something that is acidic, it means my acid now should be a strong acid plus a weak base. For me to get neutral, I can have strong acid plus now strong base. Then I will be able to use the bromothiamol blue. And then I further went on to say, for me to have a solution that is now basic, it means now I must use strong base and now use a weak acid. We further extended it to say the pH here, because it's acidic, the pH should be less than 7. The pH here should be equals to 7, and then the pH here should be greater than 7. So the key idea here, even if it's 1 mark, but if I have this principle, I'm definitely guaranteed to get the 1 mark. Because now it says, will the pH of the solution in the conical flask at the endpoint be greater than 7, smaller than 7, or equals to 7? The only way is to check what is it that I have. Do I have a weak acid? Yes. Do I have a strong base? Correct. So the relationship here is strong base, weak acid, so the pH should be greater than 7. So the answer there should be greater than 7. That's how easy it becomes. The pH will be greater than 7, because we now have a reaction between a weak acid and a strong base, and therefore the solution should be basic. And then the indicator, in this case, if I was asked to give now the indicator, it means I was going to look for phenolphthalein there. So this is just the analogy, like I said earlier on, that I am using for me to be able to remember all these things in an exam, so that I can be able to achieve maximum marks. Then 8.24. Explain the answer to question 8.23 with the aid of a balanced chemical equation. So they're basically saying we need now to look for hydrolysis of CH3 or any ions that we have here. So the idea is at 8.24, let me have CH3 COO minus, that will now react with H2O. Then this is a reversible reaction. It will give me CH3 COOH plus now OH minus. The reason for the OH minus, remember, if we have an increase in the concentration of OH minus, my pH automatically will start now to increase. So I will have an increase in OH concentrations. So OH concentrations means now the pH thereof should be somehow greater than 7. So the equation there here is just an equation that we normally use to show the relationship in terms of what happens to ions when they react in water, or the hydrolysis thereof of certain ions. So the hydrolysis of this particular ion, it says now it will give us CH3 COOH as well as the OH. So once we have an OH that is produced, it says to me my pH will be greater than 7, because I will be having more of hydroxide ions. So this will be 3 marks. It will be now the correct reactants, and then the correct products, and then 1 mark will be for balancing, and then it will be 3 marks, and then 1 mark now for that one, and then you get your total of 17 marks. So these questions are somehow similar, but the approach and the understanding is what is key. Hence we have a quite number of videos that we recorded. The idea with this was just let's look into how best can we assist you as a learner in terms of understanding each and every concept that is now in your terms and definitions that are given, because it's questions that you already have. It's questions that I feel that if you can go through all of them, if you can practice maybe without looking at the memorandum thereof and understand the concepts, you will be able to get them right. Let's try and answer question 9 in the next 10 minutes to try and cover majority of the work that we want to do. So in question 9, this one is nice because now we are given the Ka values. So remember, the first video explains the Ka value. The second video also, it has examples where now we are relating the Ka value with different type of acids, with the strength of the acid, with the ionization of the acids thereof. So hence this particular question also we need somehow to look into it. Define the term weak acid. So 9.1, a weak acid is a substance that now ionizes incompletely. I will just write it's 2 marks here for the purpose of saving time. 9.2, which acid, oxalic acid, carbonic acid, is stronger? Give a reason now for your answer. That is where I want us to go. If you check the oxalic acid, it has 5,6 multiplied by 10 to negative 2. And then carbonic acid has 4,3 multiplied by 10 to negative 7. So we can only relate the relative strength of these acids in terms of the Ka value. So the higher the Ka value, the stronger the acid. So it means for me to be able to answer this one, I will say oxalic acid is the one that is stronger. The reason is it has now a higher Ka value than carbonic acid. That is where I'm intending to go to say, let's look at the relationship of Ka together with the strength now of the acids. So the higher the Ka value greater than 1, it means now I have now a very strong acid. So in this case, it's not greater than 1, but relative to the 2, it is somehow higher. So we can easily conclude and say high Ka results now into stronger acid. So that is what I intended to explain with this particular problem. So we can easily again do the opposite to say if my Ka now is smaller than 1, then I will get a weak acid, and then I can say now low Ka results now into having a weak acid, because the Ka value will either be asked in the multiple choice, the Ka value will be also asked in your long questions. So we need somehow to be able to say something about the Ka value. Oxalic acid ionizes in water according to the following equation. Write down the formula of the 2 bases in the equation. So that is 9.3. We have the oxalic acid reacting with water and then giving us this ion here and then giving us hydronium ion. So they are saying write down the formulae of the 2 bases that are found in this particular equation. So that is where we work now with your conjugate acid-base pairs. So I already know that COOH2 is an acid, so it means it must react with a base, which is now H2H2O. And then now the other one is, remember, it should be the conjugate base of an acid, which is now one hydrogen less. So I will have Cu, which is 2, and then 2 minus. So remember, this will be now our basis in this case, because the hydronium ion relates now to an acid. So it will be my base 1 and then base 2. So it is me identifying the conjugate acid base pair. So if oxalic acid is it's an acid, it's reacting with water, which is a base, that one should be a given. And then now I need to look for the conjugate base of this particular acid, so which will be one hydrogen less, then it will give us COOO2. Then the only thing that I haven't been doing is now the distribution of marks. So I'm just going to quickly do that and say you have your 2 marks now for the definition of a weak acid. You have 1 mark for saying oxalic acid, and then higher Ka value, so you will get 2 marks, and then another 2 marks for choosing the 2 bases in the equation. So with this being said, because now 9.4, we can quickly do that, because it says learners prepare a 2 decimeter cubed hydroxide solution of concentration of 0.1 mole per decimeter cubed. Calculate now the pH of the solution. But now, if you asked to calculate the pH minus the log of concentration of H3O+, it says to me I need somehow to have information that has to do with H3O+. But the concentration that I'm given is the concentration of the sodium hydroxide. So is there a way of me linking the concentration of sodium hydroxide, which is 0.01 mole per decimeter cubed, which will just produce 1 concentration of OH minus. So is there a way of me linking the concentration of the base with the concentration of the acid? Yes, I can use Kw, which is equals to H3O plus and OH minus, then 1 multiplied by 10 to minus 14, the concentration of H3O plus, and then the concentration of 0.1, and then have the concentration of H3O plus, which will be 1 multiplied by 10 to negative 30. Then I can be able to use my pH equation, mole per decimeter cubed. pH minus the log concentration of H3O plus, which is just now minus the log concentration of 1 multiplied by 10 minus by 3 is equals to 30. So this is the easiest way of calculating that, because the information that was given now is the concentration of a base, not the concentration of H3O plus. So for me to be able to calculate that, it means I need now to move from the concentration of the base, and then from the concentration of the base use now the relationship of autoionization of water, and from the autoionization of water I will be able to get the hydronium ion concentration. Then I will be able to use in order to calculate the pH. So let's further look into the distribution of marks. You get 1 for the whole substitution here. It's just 4 marks, this one. And then you get 1 for using the pH equation, for substituting the concentration, and now for the final answer, then you get your 4 marks. So we can even try to do a quite number of problems, but generally the questions are always the same. The key idea is, let's look into what is given, and then from what is given, we calculate the unknown. So I believe for the past videos that we did together, you will be now able to understand acids and bases fully. And if you do not understand, the easiest way is play back the video a couple of times. Try to do what I tried to simulate. It's principles that have been working for me. If you have yours, maybe try to add with these ones. And then, because the idea is, if we share the strategies and the principles of doing these things together, somehow they become easy and clearer for us to do. So with acids and bases, the idea is, for your long questions, you need now to do it in a multi-step. Use the information that is given, get the number of moles. From that, use molar ratio. From the molar ratio, then you can link it to anything that is being assessed. Thereafter, the theories, the relative strength, the choice of indicators, the titration, the relative strength in terms of what will happen if I use strong plus weak base, strong acid. So all those things are things that now all the series of videos tried to cover. So in this last one, it was just an emphasis of everything that we have done. So ensure that before you watch any part, because there's a link between all the videos that we did. So start from video number 1 until now, the last video. So for me, Mr. Nambani, thank you very much, and all the best for your trial examination, and all the best for your final examination. And let's keep on working extremely hard. We shall achieve what we desire to. Thank you very much, and have a lovely day.